Hello Internet and fellow network engineers. My name is Maxim. I share videos about networking tips and tricks with you on this channel. Today we'll talk about expansion. The branch series SRX-series firewalls, certain models, have Mini-pim expansion slots. And today I will share my thoughts and experience with this guy. This is a Wi-Fi Mini-pim module for the branch SRX series. We'll cover some details about the module itself, and then I will show you the configurations from my test scenarios. And also, in the end, I will show you something special. And what we'll do, I'll show you the chassis cluster scenario for two Wi-Fi modules. So let's keep going. The Mini-pim module comes in three different flavors. There is a dedicated one for US, dedicated for Israel, and the worldwide option where you can select your own country. This specific module is compatible with SRX 320, 340, 345, 380, and 550M. Despite SRX 1500 seemingly having the same expansion slots, this module is not compatible with SRX 1500, and actually no modules are compatible with SRX 1500. So it has completely different connector in the back. The module itself is 802.11ac Wave 2 wireless standard, which is Wi-Fi 5. It is backwards compatible with 802.11ab G and N. It supports WPA2 personal, WPA2 enterprise with CCMP cipher suites. It is 2x2 multi-user MIMO. It has dual radios, 2.4 and 5 GHz, and it supports the maximum theoretical speed of 1.2 gigabits per second. You can configure up to 8 virtual access points per radio, which can be mapped to different VLANs, so theoretically up to 16 different SSID VLAN pairs. And there is a dedicated chassis cluster use case, which we'll cover. There is a picture on the right side from my lab, so with the installed module without antennas for better visibility. In my lab, I specifically used them on SRX 345 for the test. And a couple limitations to note is that if you install this type of card in the chassis, you can install just one per device at a time. But at the same time, this specific card can coexist with other cards, different type of cards. The first use case, I call it basic use case. It is similar to wireless router mode. Let's look at the diagram on the left side first. On the top, we have an uplink interface, which is layer 3 in the dedicated security zone. And southbound, we have a dedicated security zone for wireless LAN. And then we have a special type interface, which appears automatically in the configuration as soon as device boots with the module. Oh, by the way, the module is not hot insertable. You need to shut down the device to insert the module or remove it. So the WL interface, and then there is the first number, which is the number of the slot. All the interfaces on board interface slot 0. And then it depends on your model how many Mini-pim slots you have. So 345 has 4. It means 0 are onboard interfaces, and then 1, 2, 3, 4. So in my case, it's in the top, in the most right slot. It is the slot number 4. And the interface is WL400. So we configure it as a layer 3 interface. We set IP address, and we configure DHCP server on it. And then for this example, I configured two SSIDs, 2.4 and 5, and they share the same subnet. From the configuration perspective on the right side, so you can notice the interface configurations, and then security zone attachments, and then the policies, basically of your liking. And then there is a dedicated configuration section, which is WLAN, where we configure an access point. In my case, I call it my web. And then we attach the interface, wireless interface to this access point. And then you can configure separately radio 1, radio 2. So you can just use 5 GHz or only 2.4. There is no way how you can configure auto, where the client would be joining either or with a single SSID. But yeah, so you need to configure a couple if you need to use both radios at the same time. For simplicity, I just use WPA2 to personal. DHCP, pool, and the routing. So let's look at the use case number 2. This is more advanced scenario. In this case, it stays as a router mode, but we would like to separate our WLANs or SSIDs. Let's look at the diagram on the left side first. So our idea that I would like to use 2 separate sets of isolated SSIDs using different subnets, which I can then attach to different security zones. Let's say one can be a trust WLAN, another WLAN can be IoT, for example. In this scenario, you can notice the difference. The layer 3 interfaces are IRBs instead of WL. And on the right side, you can actually see how the configuration looks under the hood. So the WL4 interface is now a layer 2 trunk, which is holding VLAN 10 and VLAN 20. And then certain SSIDs are attached to VLAN 10, another attached to VLAN 20. And then as soon as they come inside the box, they are being serviced by different IRBs, which are then attached to a different security zones. And then different policies can be attached to it. Let's look at the configuration. Again, now we have layer 2 component. So we create VLANs, we attach IRBs. The next moment is very important. So you need to enable global mode switching. And if you haven't had layer 2 interfaces before, you will need to reboot your device after you enable it and configure layer 2 interface. Then you reboot it to make sure that it is working properly. You will see a commit message. So then our WL4 interface is configured as a trunk. We put 2 VLANs inside the trunk. We configure our IRBs, uplink, then security zones. And then the difference compared to the previous will be in the access point configuration. So now you can see that we have twice as many SSIDs, plus each SSID mentions VLAN ID. So it means the module, when it will be forwarding the traffic from certain SSIDs, it will be tagging it with a certain VLAN. So then DHCP and the pools. So this is the router mode advanced scenario. And then there is scenario number 3, which I tested, and I call it layer 2 use case or access point mode. So this is a layer 2 scenario where we don't want to route the traffic or, let's say, process it locally, but we just would like to tunnel it out via the layer 2. In this case, again, there are 2 sets of SSIDs, which again can be more. One is using tag 10, another is using tag 20, and then we don't want to do local processing. We just want to basically send it out to the upstream router or the firewall. In this case, there will be basically 2 trunk interfaces on both sides. And the configuration will be very simple because we don't have security zones, we don't have security policies, we don't have any layer 3, any routing. Very simple configuration. Again, there is just 2 VLANs, global mode switching, and then 2 trunk interfaces, and the WLAN component. And the final thing, which I was the most curious about, is chassis cluster use case. Let's start in this case from the right side. And we have node 0 and node 1 connected with the control and fabric links. And then the component above is familiar to those of you who set the cluster before. So we have 2 interfaces connected to upstream device, which are then combined to the redundant Ethernet interface. And then redundant Ethernet interface is set in a layer 3 mode with the family INET address of 99.1. And again, one of the interfaces is active at a time, depending on where the redundancy group is active. In our case, for simplicity, it's active standby scenario. And the node 0 on the left side is forwarding traffic, while node 1 is standing by. And on the bottom side, this is something interesting. So we have 2 modules. On the left side, it's WL4. On the right side, it's WL9, because all the slots are counted after the node 0. And what we do, we combine them into another redundant Ethernet interface. So there's a typo here. So it's a redundant Ethernet 1, and then we configure it in the layer 2 trunk mode, similar to the previous to scenario 2. But in this case, something smart happens in the background. Because the node 0 knows that it is active, it will keep its local module active, while node 1, knowing that it is secondary, it will keep its module deactivated, but ready to take mastership if something will happen. And if you look on the left side, so like a logical diagram will stay very similar to the scenario 2, where we have two sets of SSIDs isolated in different security zones with the different security parameters, plus we have a device level redundancy. Let's look at the configuration. We have SSID VLANs set, IRB attached, global mode switching, and then WL4 and WL9 interfaces are attached to redundant Ethernet 1. G000 and 500 are attached to redundant Ethernet 0, so we use only redundant Ethernet interfaces in this case. Then we have some configuration for fabric links. We have IRB configuration. And then redundant Ethernet 0 is set in the layer 3 mode and attached to redundancy group 1. And then redundant Ethernet 1 interface. And then redundant Ethernet 1 interface is also attached to redundancy group 1, but configured as a trunk interface with those two VLANs. We have a sample route, static route information, and then this is our wireless access point configuration. So the difference is that now you can notice we have two interfaces in the configuration of the wireless access point. And this is how we mentioned that they will work in a pair. The rest of the configuration is very similar to scenario 2. And then when we configure the cluster, it is recommended to enable those two wireless interfaces also in the interface monitor with the weight 255. In this case, if something will happen to the wireless card or the wireless interface, it will trigger a failover to a healthy node. And finally, we set DHCP, very similar, and the address pool information. So I hope this information will be useful to you. I personally think that it may be useful as some niche scenario for probably like a very small branch office where a single SRX-320 with a Wi-Fi module can be a device providing all-round services, including firewalling, routing, switching, and wireless. So please subscribe, and I'll see you in the next video.